All right, for homework 14, the first question says, explain why Rolle's theorem does not apply to the function even though f of a equals f of b. So even though when we plug in 0, we might get the same answers when we plug in 2, what's wrong with this function? So Rolle's theorem is just mean value theorem, special case of that. And so the rules are that f of x has to be differentiable and continuous on the interval you're looking at. So let's think about this graph. This is an absolute value graph whose vertex is at 1, 1. And if we plug in 0, we get 1 minus 1 is 0. If we plug in 2, we get 1 minus 1 is 0. Absolute value graph has this little linear segment there. So what's the problem here? There's a sharp turn at 1. So f of x is not differentiable, meaning there's no derivative, at x equals 1. So Rolle's theorem, or mean value theorem, either way, Rolle's theorem cannot be used. Okay, next one, another Rolle's theorem. The graph of f is shown. Apply Rolle's theorem and find all values c such that f prime of c equals 0 at some point between the two intercepts. So, all right, the intercepts are here. We're looking between 0 and pi over 2. So apply Rolle's theorem. So this just means that there has to be some point. I'm not even going to do the algebra here. The slope between these 2 points is 0. There has to be some point in this interval where the tangent slope is 0. It looks to be like it would be that maximum. But apply Rolle's theorem. So I would say f of x is continuous and differentiable on the interval 0 to pi over 2. 0 to pi over 2. So therefore, by Rolle's theorem, or you could say MVT, there's at least one c in that interval such that f prime of c equals 0. All right, and what is the c value? The c value is pi over 4. I can see it in the graph, but I could also take the derivative of sine of 2x and set that equal to 0 and solve, but I would also get pi over 4. All right, number 30, part A says verify that C of 3 equals C of 6. So C is the cost components used in this manufacturing process, and X is the order size in hundreds. So C of 3 is 10 times 1/3 plus 3 over 6. 2 over 6 plus 3 over 6 is 10 times 5 over 6. 10 can be divided by 2, and 6 can be divided by 2. And so that gives me 25 over 3. So let's see what C of 6 is equal to. If I plug 6 in, I get 10 times 1/6 plus 6 over 9. That's 2/3. So 1 over 6 plus 4 over 6 is again 10 times 5 over 6, and we already figured out that that was 25 over 3. So it is true that C of 3 is equal to C of 6. Okay, part B. According to Rolle's theorem, the rate of change of the cost must be 0 for some order size in this interval. Find that order size. All right, so I'm not going to do the whole, they just defined the rules for Rolle's theorem for me, so I'm just going to go ahead and carry on since that's in the problem. So we need to find C prime, but before I do that, I think I might want to, I guess I'm going to distribute the 10. So 10 over x plus 10, and maybe I'll rewrite those. Hold on, sorry. So instead of 10 over x, let's make it 10x to the negative 1 plus 10x times x plus 3 to the negative 1. So I kind of like doing this, and then I want to find c prime. So this is going to be negative 10 x to the negative 2, or over x squared. This needs a product rule in here. So plus first times derivative of the second, negative x plus 3 to the negative 2. plus second times derivative of the first. And I'm going to clean that up a bit. I just want to get rid of my negative exponents, I think. So this is going to be, instead of plus, this is going to be minus 10x over x plus 3 squared. And then this is going to be plus 10 over x plus 3. Now, if I'm allowed to use a calculator, I should not worry about simplifying this any further. I'm just looking to figure out when is this equal to 0. So if I'm allowed to use a calculator, I'm going to turn off a plot if it's on, clear out some other stuff. So I'm going to type this in, negative 10 over x squared. And then we have minus 10x over x plus 3 squared plus 10 over, remember to put parentheses around the x plus 3 expression, or remember you can also do alpha y equals to get a fraction, but I've already typed it in, so not going to do that. All right, so let me make sure I have this all typed in. Since I switched off my screen, I want to make sure I finished it. Okay, so I have this all typed in. I like to type in the line y equals 0. And then to graph this, we're looking on the interval 3 to 6. So you can set your window to a minimum of 3 and a maximum of 6 and zoom fit. We use that skill a lot in pre-calc, right? And so this is going to get me right to the answer. What's the intersection? Instead of doing 0, I'm just going to find the intersection between the curve and the line y equals 0, and I get 4.0987. So if I'm allowed to use a calculator, I'm done at this point. If I'm not allowed to use a calculator, which is possible, in order to solve when is this equal to 0, you need to get this into one rational expression. So the common denominator here is x squared times x plus 3 squared. And remember, you need to multiply each numerator by whatever you're missing to get that denominator. So the negative 10 will get multiplied by x plus 3 squared. This minus 10x will get multiplied by x squared. And the plus 10 will have to get multiplied by both x squared and an extra x plus 3, because it has x plus 3 to the first, but not squared. Okay, so then this is going to take a lot of careful algebra work. And again, I don't know, are they going to give us something like this? It is possible. So we just have to be, it's not that we don't have the math skills to do this. It's that we don't often practice being very careful as we're using all of these math skills. And if you don't practice it, then yeah, you're probably going to make mistakes. So let's see if I can do this while I was talking. So I distributed a 10x squared through, yeah. Okay. So then stuff is going to cancel. Negative 10x cubed plus 10x cubed. I need to distribute this 10 through. So I have negative 10x squared plus 30x squared, so 20x squared. Negative 10 times 6 is minus 60x minus 90. And that's over x squared times x plus 3 squared. Now, when you have a single rational expression equal to 0, remember, it's just the numerator being set equal to 0 that matters. So I can ignore my denominator. And why don't I divide by 10 to make these numbers smaller? So now I'm just looking at 0 equals 2x squared minus 6x minus 9. You might try factoring this a little bit, but it does not factor. And I know that because in my calculator I got that decimal answer, but a little bit of trial and error. If it's not factoring right away, remember the quadratic formula will solve any quadratic. So 6 plus or minus the square root of 36 minus 4 times 2 times negative 9, all over 2 times 2. This is 36 plus, because there's a negative 4 times a negative 9, plus 72, right? 8 times 9. So this is 6 plus or minus the square root of 108 all over 4. And what's 108? That's 36 times 3, right? 18. Yeah. So 6 plus or minus 6 radical 3 all over 4. And finally, you can divide by 2. 3 plus or minus 3 radical 3 all over 2. If the question is no calculator free response, you could leave your answer like this. If the calculator, or if it's multiple choice, no calculator, you're just, again, looking for the correct answer. And if it's calculator allowed, whether multiple choice or free response, like I said, you can go back here, show that you're setting this equal to 0, and then solving. And so I would have like a 0 equals right there. And then you just round your answer to 3 places and you're done. All right. What about this one? Copy the graph and sketch the line through the points A and B. So here's the secant line that goes through those 2 points. Then sketch any tangent lines to the graph for each value of C, guaranteed by the mean value theorem. So sometimes this is a multiple choice question, like it'll say like how many tangent lines are there. So you do need to sketch it through. I believe there would be 2. So it's not asking us to find the locations. We don't have the information for that. But there are 2, this is a very rough sketch, 2 C values in that interval where we would be able to imagine that there are tangents that are parallel. I did not erase my explanation for 34, so I'll just talk through this. Explain why the mean value theorem does not apply. So this is like the first problem on the interval 0 to 6. In order to use mean value theorem, f of x must be continuous, which it is, but it must be differentiable on the entire interval. And this should really be the open interval 0 to 6. The endpoints don't matter. So there is a sharp turn at x equals 2. So that means f of x is not differentiable. All right, number 37. Consider the graph of the function f of x equals negative x squared plus 5. Part A is find an equation of the secant line joining these 2 points. So for the secant line, we have 2 points we can use. So pick your favorite. You can either use -1, 4, or 2, 1 when you write your point slope formula. And then the slope is not a derivative. It's just the slope between those 2 points. So like 4 minus 1 over -1 minus 2. 3 over -3 is -1. So the equation could either be y minus 4 equals negative x plus 1, or it could be y minus 1 equals negative x minus 2. Either one. All right, and then for part B, use the mean value theorem to determine a point C in the interval -1 to 2, excuse me, such that the line at C is parallel to the secant line. So before I can use mean value theorem, I need to cite what it is. So f of x is, this is kind of a script, continuous and differentiable on -1 to 2 on that interval. And they used an open interval. I guess I should too. So on that interval, so by mean value theorem, there's at least one C, and then C has to fall between these 2 values, such that f prime of C equals this slope, which is -1. So the official, I already did the work here, but the official thing would be equals f of 2 minus f of -1 over 2 minus -1. But we already said that's equal to -1. So what do we do with the f prime of C side? Well, they gave us an f of x. So f prime of x is equal to -2x plus 0, right? So f prime of C is equal to -2c. And then we just solve for C. Divide by -2. So C must be positive 1/2. Okay, and then part C says find the equation of the tangent line through C. Okay, so we need a point. So we need to know what is f of 1/2. That's -1/2 squared is 1/4 plus 5. So -1/4 plus 20 over 4 is 19 over 4. All right, and let's see. Oh, you know what? I should have found that back in part B. I found C, but point C is 1/2 19 over 4. Sorry about that. All right, so anyway, I have that point, and then the slope, remember, we already know that f prime of 1/2 of that c value, we already know the slope is -1. You could plug it in to your f prime equation again if you wanted to. And so the point slope equation is y minus 19 over 4 equals negative x minus 1/2. And part D just says graph everything, graph the function, the secant line, and the tangent line. So I did that here. And yeah, it's a good visual for saying like, okay, the tangent line, this looks tangent and it looks parallel to this one. In number 43, determine whether the mean value theorem can be applied on the interval. If it can be applied, find all values C. If it can't be applied, then explain why not. So x to the 2/3 on the interval 0 to 1. So to determine if I can use it or not, we need to look at f prime of x and see if it's defined on this interval. So x to the 2/3 becomes 2/3 x to the -1/3, which is 2 over 3 cube root of x. Is that defined on the open interval? It doesn't matter about the endpoints, but is that defined on the open interval 0 to 1? So I can't plug in 0, but we don't have to include 0. We're looking at anything between 0 and 1. So yeah, f prime of x exists between 0 and 1. So since this exists, I can say f of x is continuous because I can plug into x to the 2/3, continuous and differentiable because I know that the f prime graph is continuous on the open interval 0 to 1. So by mean value theorem, this is annoying to write out, but the more you write it out, the more likely you are to get it right on the test. There's at least one c between 0 and 1 such that f prime of c equals f of 1 minus f of 0 all over 1 minus 0. The derivative, there's a tangent slope that's equal to a secant slope somewhere on this interval. Okay, so we have to find what that is. F prime of c, we already have an f prime equation. It's 2 over 3 cube root of c. And what is f of 1? So f of 1 is 1 minus 0 over 1 minus 0. So when is 2 over 3 cube root of c equal to 1? So I'm going to multiply the 3 cube root of c over to this one side, divide by 3. To get rid of a cube root, I need to raise both sides to the third power. So c is equal to 8 over 27. All right, same directions for number 51. Excuse me. So for 51, double check from 1 to 9, is this continuous? Yes. And we also need to find f prime of x. That's 1/2 x to the -1/2, so square root goes under there. That's defined on 1 to 9, right? There are no discontinuities there. So I'm going to write basically the same thing I wrote up here. F of x is continuous and differentiable on the open interval 1 to 9, also the closed interval, by mean value theorem. There's at least one c between 1 and 9 such that f prime of c equals f of 9 minus f of 1 over 9 minus 1. Plug c into your f prime equation. Calculate using the f equation. So square root of 9 is 3 minus square root of 1 over, that's 8. 2 over 8 is 1/4. Multiply the 4 to this side and the 2 radical c to this side. Divide by 2. Square both sides. So c equals 4 for that one. In calculus, it's often the algebra stuff that messes you up. It's not necessarily the calculus, even though this is annoying to write out. The calculus stopped right here. The rest of this was algebra, or algebra 2, I guess. Okay, number 59. A plane takes off at 2 p.m. on a 2,500 mile flight. After 5.5 hours, the plane arrives at its destination. Explain why there are at least 2 times during the flight when the speed of the plane is 400 miles per hour. This is kind of like the speeding ticket problem in our notes. So we want to look at, well, first of all, we want to note that, so there's some sort of speed function, right? A speed function, because you can't just jump from, 350 miles per hour to 400 miles per hour, you have to hit everything between 350 and 400. I know that the speed function is continuous and differentiable because it's a smooth function. There is no just sudden change in speed. You have to gradually change speeds. You can't skip over something. So anyway, I know the speed function is continuous and differentiable. So by mean value theorem, there is, now the mean value theorem says at least one. They're saying at least two. We'll talk about that. At least one C that's, I'm going to say, instead of like between this and this, I'm going to say there's one C in the 5.5 hours span, maybe in the 5.5 hour span, such that the speed is equal to, the instantaneous speed is equal to, let's see, we did 2,500 miles in a total of 5.5 hours. That's an average rate of change. And what is 2,500 divided by 5.5? That's about 454.545 miles per hour. So I know that there's an instantaneous speed that's as fast as this. And again, because you can't just jump from, say, 300 miles an hour up to 454 without hitting everything in between, you've got to hit 400 miles at some point. And so if that's the max, if that's not our max, sorry, if that's the speed that we have overall, then there's got to be probably 2 times. I'm assuming 2 times because we have like on the way up and on the way down. Like on takeoff, maybe they hit 400, and then on like when landing, perhaps that's why they're saying 2. But again, I assume the plane's path is maybe not parabolic, but it definitely has some sort of an arch to it. So that's my guess there. Okay, number 60. When an object is removed from a furnace and placed in an environment with a constant temperature of 90 degrees Fahrenheit, its core temperature is 1,500 degrees Fahrenheit. 5 hours later, it drops to 390. Explain why there must exist a time in the interval when the temperature hits 222. So same idea. This is a temperature function. And a temperature function, for the same reason as speed, I know it's continuous and differentiable. It's a smooth transition from 1,500 down to 390. You're not going to suddenly skip or jump to anything or have a sharp turn. So because of that, by MVT, there's at least one time in the, how many hours? 5 hours, where, or such that, the temperature, the instantaneous temperature, is equal to, what is this drop? 1,500 minus 390 in a span of 5 hours. So 1,500 minus 390, divide that by 5, comes out to exactly 222. So there's got to be at least one time where that's true. Sketch the graph of an arbitrary function that satisfies the given condition but does not satisfy mean value theorem. So we need a continuous function, but it's not differentiable everywhere. So to me, that's sharp turn. So I'm just going to do an absolute value function. Like here's -5 to 5. This graph is continuous, but it is not differentiable. I can't use mean value theorem because at x equals 0, there's a discontinuity. So f of x has a sharp turn at x equals 0 for my picture. You can draw anything with a sharp turn, but it's got to be continuous, so no asymptotes, no jumps. Anything with a sharp turn. Therefore, f of x is not differentiable on negative 5 to 5 for every value. All right, true and false. I left my answers up here, so I will just talk through these. The mean value theorem can be applied to 1 over x on the interval negative 1 to 1. 1 over x is that graph that looks like this. It's discontinuous at x equals 0. So false. The first thing is that f has to be continuous and differentiable. 78. If the graph of a function has 3x intercepts, then it must have at least 2 points at which the tangent line is horizontal. You might have originally sketched something that looks polynomial, but it doesn't have to be polynomial. You could have sharp turns at those places, and so then the tangent line is not horizontal at the sharp turn. It actually just doesn't exist. Okay, for number 79, so they've changed it slightly. So now it is a polynomial function. If it's got 3x intercepts, then yes, you're going to have at least 2 horizontal tangent lines. You could even put like bounces in there or where the graph touches and turns, and you would have more than 2, but it says at least 2. And then for 80, f prime of x equals 0 for all x in the domain of f. If that's true, then f has to be constant. And that's got to be true because if a derivative is 0, that means that the original function was a constant function. So yeah, that's a horizontal line. All right, please come into office hours if you want more explanation with any of these or if you're having trouble on any of these topics.